Okay, welcome folks. This is law number 1 for gas laws, Avogadro's law. Quick side note here. All summer long, your teachers were taking PD about best practices for making videos, and they highly encouraged my face in the video. Well, the video software that they gave me to do that stinks. So you're going to go back to the old software and not see my face, but I'll promise I'll show you my face enough. That's me being frustrated. Sorry. All right, so Avogadro's law. This is the first law that is formed from kinetic molecular theory. Remember, a theory is a vast explanation of a phenomenon, where laws are particular explanations and or equations for one little piece of that phenomenon. So Avogadro has pointed out, when you look at kinetic molecular theory, that equal volumes of any gas at the same temperature and pressure will contain the same number of particles. And we're going to take a moment here and define same temperature and same pressure. So scientists over time have standardized the idea of temperature to be 0 degrees Celsius or 273 kelvins. Celsius is the relative of the Fahrenheit. It's just another way that we do temperature in the world. And kelvins are a way to measure the molecular movement at a particular pressure and volume. So in order to get from Celsius to kelvins, you add 273. Standard pressure is defined as 1 atmosphere or 100 kPa. ATMs is the abbreviation for atmospheric units. Olympia, Washington is at 1 ATM. That's because we're at sea level. And kilopascals means 1,000 pascals. And the pascal is the SI unit for pressure. And to just give you a basis of what that means, it's equivalent to approximately 0.000145 pounds per square inch. Very, 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 very tiny. So if we take this to be standard temperature and we take this to be standard pressure, let's see what that looks like mathematically. We already know Avogadro stated that that 1 mole of anything contains 6.02 times 10 to the 23rd particles. Here's the big takeaway from this whole entire video. At STP, standard temperature and pressure, 1 mole of any gas will have the volume of 22.7 liters. End of discussion, always, always, always till the end of time. So, I put on here, that's muy importante. Please make a note of it, and I will give you a second to do that. You're going to see a graph in the middle of your screen. What that graph indicates is the relationship between volume and the number of moles. As you increase the number of moles, you will increase the volume proportionally, and the slope of this line is 22.7. So what we're saying here, as number of moles increase, the volume will increase at a proportional rate. 22.7 per every mole. Let's put this into mathematical practice. All right, so how many moles of krypton are found in a 16.0 decimeter cubed sample at STP? So this is how simple this is to solve out. We know moles, the symbol is going to be lowercase n. And we know I've got 16.0 decimeters cubed of krypton. And I've got in 1 mole 22.7 decimeters cubed. Recall that decimeters cubed is the IB way of saying the liter. So all this turns into is, when I cancel out decimeter cubed, is 16.0 divided by 22.7. And when I grab my calculator and solve that out, I get 16 divided by 22.7. And don't forget our lovely friends, the sig figs. I know you missed me saying that. So I've got 7.05 moles krypton, quantity, unit, substance. It's just that simple. There are no practice problems that are going to go along with this particular video, but we're going to come back to Avogadro's law soon.